Let's take a look at this indefinite integral, the integral from -2 to 1 of 1 over the cube root of t dt. Now, at first blush, this is not obviously an indefinite integral. Some indefinite integrals have an infinity, either negative infinity down here or a plus infinity up here. This one is a indefinite integral because there's a problem with the integrand. Clearly, if t is equal to 0, then the integral here diverges, the integrand diverges, 1 over 0 blows up. So there's a singularity in the graph. So if I were to graph this thing, the graph would look something like this. And so here's -2, here's 1. And so the issue is to try to find this area if I can. And there is a singularity in the middle, where a place where it blows up. So because I have this singularity, this place where the integrand blows up when in somewhere between -2 and 1, I have to apply the techniques of indefinite integrals. So the technique we use for this, integral from -2 to 1 of 1 over the cube root of t dt. Okay, this we will split up into two separate things. So this is going to be the limit as b approaches 0 from below of -2 to b 1 over cube root of t dt. So let me stop there. So we're going to take a b over here and let b get closer and closer to 0. And that will give me an approximation to this part here that I've part in red. Then I will have a second limit plus the limit as a approaches 0 from above of a to 1 of 1 over the cube root of t dt. So the idea here is there's an a here. This a is going to get closer and closer to 0. And so I will find the area here that I'm highlighting in green and let the area in green get closer and closer to the y-axis. So I have two separate limits that I have to figure out. Okay, so first we deal with the integrals. Now, fortunately, the integrals are pretty straightforward. So let me deal with the integral first. The integral of 1 over the cube root of t, that is equal to 3/2 times t to the 2/3 evaluated from b to -2. And then for the second limit, I have the limit as a goes to 0 from above of the integral is again the same thing, 3/2 t to the 2/3 evaluated from 1 to a. Okay, so now we are able to compute these things. So now I'm going to keep this one in red and this one in green. So we have 3/2 times b to the 2/3 minus 3/2 times -2 to the 2/3. Okay, so that's straightforward. The second limit, we have the limit as a goes to 0 from above. Plugging in 1, I get 3/2. 1 to the anything is equal to 1 minus 3/2 times a to the 2/3. Okay, now we compute the limits. As b goes to 0 from either above or below, b to the 2/3, that goes to 0. I have a positive exponent here. It's a fraction, but it's a positive exponent. B to a positive exponent as b goes to 0 goes to 0. There's no problem with singularities or anything like that. I can plug in 0. 0 squared is 0. Cube root of that is 0. So there's no trouble plugging in b equals 0 here. 0 plus 3/2 times, now this I can simplify a bit. -2, I have 2 squared is 4. So that works out to be the cube root of 4. -2 squared is 4. Then I take the cube root. Plus, over here I have 3/2 minus, now once again, by the exact same reasoning, 0 to the 2/3, 0 to a positive exponent, that is 0. So I have -0. And so in conclusion, I have that this is equal to, and I apologize, I just caught, this should have been a minus sign. sorry about that. I have this is equal to negative 3 halves times the cube root of 4 plus 3 halves. And so, and obviously we were able to find the answer, and so the integral converges.